Hi everyone, on this video we will talk about law and variable. So when we talk about laws, we are talking about formulas in mathematics or scientific formulas, it doesn't matter. So we will do some change on the formulas, that's all. So this is a rule for polyhedrons. The number of vertices and the number of faces with the number of sides in such a way, there's an equation between them. So vertices plus number of faces is equals side plus 2. So this means, for example, 1, 2, 3, 4 vertices, 4 plus 3, 1, 2, 3, 4 sides, it's equal 1, 2, 3, 4, 5, 6 plus 2, so 8 is equal to 8. So that's a rule, that's a general rule for polyhedrons. You can check what is the polyhedrons on the net, on the Google, no problem. This is not my rule. What will we do with these rules? It's important here. For example, we will change that rule, use the formula volume plus face, it's equal side plus 2, write each variable in terms of the other variables. So we are going to write V in the terms of others. V plus F, it's equal side plus 2. So my main target, writing V equals something. So the volume must be, vertices must be equal something. So how can I isolate this V here? If I subtract both sides, if I take away F, the faces from the both sides, there will be 0. So only V will be left. So let's continue from there. Therefore, volume, V is equal S plus 2 minus F. So you can say the constants we usually write at the end of the sentences. So side minus face plus 2, it's equal to the number of the vertices. So it's same with the algebraic expressions you learned before. Only the things change. We didn't subtract the numbers or the same variable. We subtract other things. For example, if this is FF. Let's continue. V plus F. It must be S plus 2. As you see, it says write the S on in the terms of others. In terms of others. So where is the S is here in the equation. How can I isolate this S? If there is an S, there is a plus 2 extra. I need to cancel that one. So if there is a plus 2, if I add both sides, negative 2. So if I take from the both side equation minus 2, the equation will not change, of course. So volume plus F minus 2, it's equal S, only SF. So this is an equation. I can write S equal V plus F minus 2. So I find the S and it's equal that term. Next. Okay, there is a rule M equal T times H, write H in terms of the other variable. So M equal T multiplied by H. So there is nothing signed T times H. We read it T times H. So T times H. So I want to write H by the other terms. There is a T times H. I don't want this T here. So if I divide both sides by T, so T divided by T will be 1. Only H, 1 H will left. And M divided by T will be other side. So M divided by T is equal H. H is equal to M divided by T. Okay, there is a formula. This is the pi times R squared multiplied by H. So A equal pi times R squared multiplied by H. So it's write the H by the other terms. In the terms of others, we need to keep the H here. So I need to cancel other things. P times R squared times H. So these are multiplication. How can I cancel it? If I divide both sides by same term. So pi R squared. So this will be 1. Any number divided by itself will be none. Only H will left here. So A divided by pi times R squared, it will be H. So H is equal A divided pi times R squared. So these two things, it's same. If a divide pi of r square is equal to h, so h is equal to a. You can read the opposite sides. That's an equation. It doesn't change when how you write it. Let's continue what we have. Area is equal to pi times r square. This rule, if you remember, area of the circle. So area is equal to pi times r square. So it says write r in the terms of other. Just be careful here because r has a square. So this is together. That's we cannot simplify it. But I have pi here. First I can simplify this pi. If I divide both sides by pi, if we divide both sides by pi, so what we will have? We will have area over pi is equal r square. So instead of that one, it's right. I can change the place. So I can directly write r square is equal area over pi. So nothing changed. Just sides change. No problem. We can do that. There's a square. So if I use square root, so square and root can cancel each other. Only r will be left. But be careful because r on the square it can be negative or positive. So let's use square root. Radius can be equal. So this is the r is equal to under the square root area over pi, or r is equal minus under the square root a over pi. Here be careful. The r is here radius. So what does it mean radius? Let's make a review. Let's draw a circle here. The radius, the distance from center to the circle, the shortest distance, the r. This is the r radius. So the distance cannot be negative. Therefore, we cannot write that one as a solution because radius is a distance. It cannot be negative. Only that one true for this equation. So r equals square root under the square root a over pi, square root of a divided by pi. Okay, let's continue. So where x is positive, write x in the terms of y. This is important. It's a x is positive. So let's continue. Pay attention here. X is positive. So y is equal x squared minus 1. There's a minus 1, then it's another term. X squared is here one term, but there's another term minus 1. To cancel this term, I will add plus 1, put plus 1 both sides. So y plus 1 it's equal x squared. I can say x squared equal y plus 1. So let's continue from there. Okay. X squared equal y plus 1. So there is an x squared. We can use square root both sides. X will be equal square root of y plus 1, or x can be equal negative of it. But there is a condition at the beginning of question. X is positive. Because x is positive, I cannot use that part. I can only say x is equal square root of y plus 1. That's our solution. This is not, because x cannot be negative. In the question it says x is positive, so it cannot be negative. Okay, there is a relation between Celsius and Fahrenheit. So the rules say 9 times Celsius equal 5 times Fahrenheit minus 160. So write C in the terms of F. So I need to isolate C. Where is the C? Here. It has a coefficient 9. So if I divide both sides by 9, all of them, of course. When you divided one side by a number, or when you multiply one side by another number, you need to do it all terms on the side. So 9 divided by 9 is 1. Only C is left, equal 5F minus 160 divided by 9. So this is important. Why it's important? When you divided one side, you need to divide everything, every term on the sides. Not only 5F, not only 106, all terms. That's the important part. Let's continue this time you say write F in the terms of Celsius or C, no problem. 9 times C equal 5 times F minus 160. So I want to isolate F, that's the terms of F, 5F. So there is 160. If I add both sides 160, so 9, sorry, it's not black. 9C plus 160, it's equal 5F. Okay, when you, I don't want 5 times F, I want to write F by the terms of C, so I don't want this 5. If 5 times F, I can divide by 5 both sides. When you divide both sides, you need to divide everything on the other side by 5. So 5 divided by 5 will be 1, only F left. So you can say, sorry, I couldn't choose the black again. F is equal 9C plus 160 over 5. Okay, not that much. It says n. This n shows us you have to write in the term of this variable. It's in the, if you read the question, write each variable in terms of the other variables. So n is given. I will keep this n and I will isolate n on the one side of the equation. X plus 4 is equal n plus y. So the n is here. After n, there is a plus y. There is another term. So I can simplify this term if I add both sides negative y and negative y. So as we know, plus y and minus y will be 0. Only n will left. So n is equal. I can change the sides, no problem. N is equal x minus y and plus 4. Don't forget the signs belong to their terms, so that I can change the terms place. If you don't remember these things, you can watch the video terms of algebraic expressions. Okay, this time we need to isolate the x. So x plus 3y equal to n minus 5. Here's a good question. Why? There's a term near to x plus 3y. To make it gone, I can add both sides minus 3y minus 3y. So only x will be on the left side. So 2n minus 3y minus 5. So that's it. Let's solve some more question about square root, because in your book, that's my students, there are some conditions given. For example, it's isolate the x, but x must be bigger than 0 and y is bigger than 0. These two conditions. As you see, x squared, x only has square, the other side 3y plus 4. So to make the square gone, I can use square root both sides. So x can be equal square root of 3y plus 4, or x can be equal square root of, so negative of it, so I forget, I already write positive one, negative of it, square root of 3y plus 4. But here there is a one condition. It says x is bigger than 0, so x cannot be negative. You can ask me, teacher, why the y is bigger than 0 is given? Because at the moment we are talking numbers, so we haven't learned a complex number. So inside the square root cannot be negative at the moment. So therefore we need to keep inside positive. So y must be bigger than 0 to keep the inside square root greater than 0. So what is my solution here? Only one of them. X is equal under the square root 3y plus 4. Okay, let's see that one. It say isolate the y, so 2x equal y square minus 4. Y is here. I have another term, negative 4. So this, I need to cancel this term first. Plus 4 plus 4. 2x plus 4, it's equal y square. So to cancel it, I can use the square root both sides. So y is equal square root of 2x plus 4, or negative of it. Y is equal negative square root 2x plus 4. But we have to check the condition. What is the condition here? X is bigger than 0. It's inside the square root, so it must be positive. And y is smaller than 0. If y is smaller than 0, this cannot be my solution. My solution must be y negative. So y is minus under the square root 2x plus 4. So this is my solution, and that's end of the